All right, this video is for Unit 6, Section 5 notes. We're almost done with this unit. So we're going to be finding the trigonometric values of any angle. Okay, so until now we've been working with trigonometric values that pertain to an angle of rotation. Now we're going to move on to trigonometric values of any function. So there's another definition of trigonometric functions using right triangles. So in a right triangle, okay, so here's the right angle. So this side is always the hypotenuse. And if we're talking about, say, this angle here, okay, the other leg of the right triangle that forms that angle, that touches that angle, is called the adjacent side. And then the other side of the triangle that does not touch that angle is called the opposite side. And so we can use these links to find these trigonometric ratios. So sine is going to be, and I'm just going to use abbreviations here. I'm going to use H for hypotenuse, O for opposite, and a big A for adjacent. So sine of an angle is opposite over the hypotenuse. Cosine is adjacent over the hypotenuse. Tangent is opposite over adjacent. Cosecant is hypotenuse over opposite. So it's opposite. If you can, these two are opposites of each other. Secant is hypotenuse over adjacent. Again, and then cotangent is adjacent over opposite. Okay, so what does all this mean? These definitions can help us in many situations throughout the next few units. So if the terminal side of an angle in standard position passes through the point P, draw an angle and find the exact value of the 6 trigonometric functions at the angle. So the point here that they gave us is 8, 6. So 8, 6 would be over 8 up 6. So we're estimating here, okay? So here's our angle. And so what that means is that if I kind of create a triangle out of this angle, okay, we went over 8, we went up 6. And so to find this hypotenuse, we would use Pythagorean theorem, which is a squared plus b squared equals c squared. C is always the hypotenuse. So we would do 6 squared plus 8 squared equals c squared. And so let me kind of show you what that looks like in a calculator. Okay, so let back up. So 6 squared plus 8 squared is going to give me 100. And that equals c squared. So I can square root that 100 to find the value of c. So that means the c would equal 10. That's this side here. Okay, so we don't know what this angle measure is, right? But we can find the trig ratios of this stuff, okay? So the sine of the angle, so sine is opposite over hypotenuse. So this angle, the 8 would be the adjacent, the 6 would be the opposite, and the 10 is always the hypotenuse, okay? So opposite would be 6 over 10, and that simplifies to 3 over 5. Cosine of that angle would be adjacent, which is the 8 over 10, which simplifies to 4 over 5. Tangent of that angle, opposite over adjacent, so 6 over 8, would be simplifies to 3/4. Cosecant, which is hypotenuse over opposite. And so it flips. So you see how these flip? Secant, hypotenuse over adjacent, which is the opposite of the cosine. So again, they just flip. Sorry, I'm starting to write really small there. And then cotangent of the angle adjacent over opposite would be 4 over 3. So again, reciprocal relationships between this set and this set. Okay. There's another way that we can use these values as well. So what I want to show you again in the calculator, I can find the measure of that angle. I can find the measure of this angle using any of these relationships. What I would use is the inverse. So it would be sine to the -1. And I know the side ratio is this. So in the calculator, let me make sure that mine is, make sure that it's on degree. That's what it needs to be on. So we would do this trig key here, sine to the -1. And then we would do, so it's 3/5. Okay. And it gives me the approximate measure of that angle. Okay. So that's how these are used. We're not really doing that in this, but I want you to see that relationship. Okay. So the next page here, we're doing the exact same thing. Okay. So we've got these values here. And so 2, here's our point. We would go over 2, and then the negative square root of 3 is going to be down this way somewhere. Okay, so here's our angle, and that means this distance is the negative square root of 3. The x distance is 2. And then to find this, so we would do 2 squared. I need more room than this. Let's do it here. 2 squared plus the negative square root of 3. This whole thing gets squared, equals c squared. What this is 4. This would be a positive 3. Okay, positive 3. Actually, let me check that really quick because my brain is saying no, but I think that's correct. Actually, I can do it this way. If I do square root of 3 and then I square it, yeah, positive 3. Okay, just want to make sure my brain was telling me something different. Equals c squared. That means 7 equals c squared. That means the square root of 7 equals c. So they're not always really pretty. Okay. So back to those ratios. We need those ratios. There's a way to remember these, and it's called SOHCAHTOA. S-O-H, so, ca, C-A-H, and then TOA, T-O-A. It's an easy way to remember those trig ratios there. So sine of the angle. So the angle that we have is right here. Here's my angle. So this is opposite. This is adjacent. Always make sure you kind of can identify those pieces. Square root of 7. So opposite would be the negative square root of 3 over the hypotenuse. And then again, if you get rid of this on the bottom, you end up with, I want to say it's like the negative square root of 21 over 7, something like that when you combine everything down. We'll look deeper into it, work through the math a little bit more later on. So cosine is going to be adjacent 2 over the square root of 7. Again, rationalizing your denominator, 2 times the square root of 7 over 7. Tangent of that angle is going to be the opposite, so negative square root of 3 over the adjacent, which is 2. That doesn't simplify down anymore. Cosecant of the angle is the hypotenuse. So again, we just flip it. And then again, rationalizing the denominator here, we would have the negative square root of 21 over 3. And then secant would be the hypotenuse. Hypotenuse over the adjacent, which is 2. And then cotangent would be the adjacent, cotangent, over the opposite, negative square root of 3. Rationalizing it looks something like that. Okay, so just being able to fill in those ratios is kind of what this topic is about. So let's do One more. Negative 15, negative 8. We'd go over negative 15, down negative 8. Okay, so that means this is my angle here. Okay, but I can still use this triangle here. So this would be negative 15. This would be negative 8. So negative 8 squared plus negative 15 squared equals c squared. For time's sake, c is going to equal 17. I'm going to trust her on this one. So this is opposite. This is adjacent. So one more time through these. Sine of an angle is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, which the negatives would cancel out. Cosecant of the angle is the hypotenuse over the opposite. So again, just flipping all of these. Secant of the angle would be 17 over negative 15, and cotangent of the angle, we just flip it, 15 over 8. Okay, so that's just writing the ratios. This one says find the exact values of the other 5 trig functions for an angle in standard position given the following. Sine of an angle, okay, the sine of an angle equals negative 12 over 13, comma, and then this is your boundary, okay? 3 pi over 2, the angle is in between 3 pi over 2 and 2 pi. So going all the way back to that unit circle we built. Okay, that's 270 degrees. So the angle is in between 270 and 2 pi is 360. Okay, that's all that's telling me. So here's what we know. Sine of an angle is opposite over hypotenuse, equals opposite over hypotenuse, which means 12 and 13. And here's why we have this. One of these has to be negative. We don't know which one. We know it has to be in this quadrant. Negative 12 would mean I'm going this way on the x-axis. So that's not possible. We know the 13 is the negative. Okay. Looking at our other triangles here. So again, hypotenuse we know is negative 13. So we can fill in the blanks here. So we know our angle is somewhere here. We know that this measure is, that does not make any sense whatsoever. I'm sorry, I did that backwards. The 12 is the negative. I was looking at the adjacent side. We know this side is 13, the hypotenuse. Okay. This is going to be the 12 side. So if we do reverse Pythagorean theorem, right, we're trying to find the x value, x squared plus, this is a negative 12. Negative 12 squared equals 13 squared. And we solve that out. We're going to get that the x value is 5. This distance here is 5. Now our angle is all the way around this way. Okay. So what we do know is that this is our opposite. This is our adjacent. Okay. And then we can fill in the rest of these. So cosine of an angle. So back, and I don't know that I can get all of these to show up. Cosine, adjacent over hypotenuse. So 5 over 13. Tangent is opposite over adjacent. So negative 12 over 5. And then again, we can just flip these. So cosecant, we would just flip this ratio here. It would be 13 over negative 12. Secant of an angle, we would just flip this one, would be 13 over 5. And then cotangent of the angle would just be 5 over negative 12. Okay, secant of an angle is negative 2. Okay, so secant, we know that secant of an angle is hypotenuse over adjacent, hypotenuse over adjacent. And then we know this value, negative 2 is 2 over 1. The hypotenuse cannot be negative. Okay, that's not a possibility. Okay, so here's our angle measure between pi and 2 pi. So that just means it's down here somewhere. So we could use a negative x. Okay, so that means our angle is out this way. Our hypotenuse is 2. This is negative 1. And then this side would be the negative square root of 3. I know it's negative. Sorry, you can't see that because we're going down here. Okay, that's the only reason that I know that one is negative. Our angle wraps around this way. Okay. Okay, so let's start off here. So sine of an angle. So again, this is where that SOHCAHTOA comes in. Okay, SOHCAHTOA. So this is the adjacent angle this time. This is the opposite. So sine is going to be the opposite, negative square root of 3 over the hypotenuse. Cosine of an angle, adjacent, so negative 1. And then tangent of the angle is going to be the opposite, negative square root of 3 over negative 1. That just simplifies to a positive square root of 3. So cosecant, again, remember, you can just flip them. 2 over the negative square root of 3 or negative 2 times the square root of 3 over 3. Rationalize your denominators. And then we've already got secant, so we need cotangent, which is the inverse of this one. So it would be a negative 1 over the negative square root of 3. Again, those are going to cancel out. The negatives are going to cancel out. And we're left with the square root of 3 over 3. So that's it for this set of notes.